Today, we're going to learn how to do excess reactant, limiting reactant, like how to solve a full problem of just that, not percent yield, but just like that, you know? Here is the problem, and as you can see, like all the questions, I've already tried setting it up right now. So yeah, let's get started. So basically, first we're just going to put our setup, which is going to be the number that we were given, which is 58.1. And we're going to put the molar mass of this and how many moles of this is inside the equation, which is just 1, since there's only 1 right here. And I'm going to put the molar mass of this compound, MgOH2, up here by the amount of moles, which is 3. And yeah. And as you can see, I did this all, and this comes out to, sorry, just cut out, but it's 101 grams. Oh, well, there we go. Now we have to do the H2O, which is 4.87 times 10 to the 24th. We're going to do that right here, and I'm just going to set it up 1 second. So since it's a particles problem, we're going to multiply the number that we're given by 6.022 times 10 to the 23rd in order to get the bottom number. And for that, I got 3.6132 times 10 to the 24th. And since we already found the MgOH2 up here, we can just put that same number down here. And now we just plug this into our calculator. This entire equation, actually. And I got 236. Now, if you know anything about like limiting reactants and stuff, the lowest number is always going to be the limiting reactant. So basically, this number does not matter. Even though we did all this work, it does not matter. This is the Ty, which is theoretical yield. This is the Lr, and this is the ER, limiting reactant, excess reactant. The amount of hydroxide of magnesium hydroxide produced was 101 because it's the most logical number, and it doesn't make any sense for it to be 236. Now, since it's asking for how many grams of ammonia gas will be released, we know that this thing is not a real number anymore. I mean, well, it doesn't matter to us right now in this problem. What we know is that this is the actual limiting reactant, which is the MgN2. So we're going to use 58.1 to solve and change to ammonia, which is N2, which is going to be the exact same thing over here, except it's just going to be N2 instead of MgOH2. And I got 19.6. Okay, so now I've gone to here, and we're just doing the exact same thing, except that we did here is just we're changing this into the excess reactant, which was, as we see here, the H2O. And now, as we just did the exact same thing, I literally used the exact same numbers. I subtracted the excess reactant, which is 4.87, from 2.8, that was used, and I got 2.79.